Students, today I am taking up a session on the chapter number 1, number systems of class 9 of our NCERT textbook. In this we have one topic where we have to represent the decimal numbers which are of the form non-terminating repeating. So these decimal numbers are to be expressed in rational form. So these numbers are in the form of a bar over some digits. That means that part is repeating and that part is non-terminating also. So these kind of numbers in decimal form can be expressed in rational forms, that is P by Q form, with a certain method. So this method I will discuss with you in details. We will take the numbers where there is a bar over a single digit, then bar over two digits or bar over three digits. All the different examples and cases we will consider one by one. So here it is. Expressing decimal numbers in P by Q form, the decimal number is non-terminating but repeating, and the portion which is repeated there will be a bar over it. So first I will consider where there is a bar over only one digit. Then I will take one example where there is a bar over two digits. Then I will take one example when it is expressed in the form of the non-terminating and repeating number. Then we will convert it to 1.27 bar like this, and then we will solve it. And one example I will take this 15.712 where bar is only over 1 2. In rest of the examples the bar is over all the digits after the decimal place like this. After decimal we are having all the bars, but one example I will take where the bar is over selective digits. So let us take example number 1 first, which is 0.7 bar. So we need to convert it to rational form, so I will first take it as x. Let x equal to 0.7 bar. Now x can be written as 0.777 and so on. This is expansion, so I will write it as 0.7 and 7 bar. So bar I have shifted to this one to show the continuation. So this will be my equation number 1. After that I will multiply, since in this question there is one digit after decimal, I will multiply it with 10 on both sides. I will get 10x equal to 10 into 0.77 bar. So 10x is equal to, because of this 10 decimal shifts to one place, I will get 7.7 bar. So this will become my equation number 2. Now I will subtract equation number 1 from equation number 2. So I will get 10x minus x equal to 7.7 bar minus 0.7 bar. The original equation we will take as equation 1. So now 10x minus x is 9x, and when I am subtracting it, 7.7 bar minus 0.7 bar, then this 7 bar and 7 bar are becoming 0, and this becomes 7 minus 0, 7. It will come as 7. So 9x is equal to 7 and x is equal to 7 by 9. So this is the rational representation of our decimal number. Now our next example, 0.35 bar. Again we will assume it to be x. Let x equals to 0.35 bar. This will be equation number 1. Again it can be written as 0.35, 35, 35 and so on. 35 will be repeated, and I can write it x equals to 0.35 and the bar shifts to the next one. Then I will be multiplying it both sides with 100 this time, as there are two decimal places after the decimal. There are two places, so I am multiplying with 100. So this becomes 100x equal to 100 into 0.3535 bar. So because of these two zeros, decimal shifts to next two digits and it becomes 35.35 bar. Now this will become equation number 2. Subtracting equation 1 from equation number 2. What I get is 100x minus x equals to 35.35 bar minus 0.35 bar. So this becomes 99x equal to, again this part after the decimal gets subtracted becomes 0, 35.0 or 35. So x comes out to be 35 by 99. So this is the rational representation of a decimal number where the bar is over 2 digits. So third example is 1.27 bar. This will be done exactly as this method, multiplying with 100 and then the subtraction to be carried out.